Now, in order to access the application, we had to go to the AWS UI, we had to get the DNS endpoint of the application. We also need to know which port it's running on, etc. And then we can type it in the browser. Now, let's say we don't want to search for this information every time we build an application. Instead, we wanted this logic to be inside the pipeline so that whenever we execute it and the application gets deployed, we have an overview somewhere where we can just click on a link and it takes us to the deployment endpoint. Can we do that in GitLab? We can actually, using a feature from GitLab called environment. So as I mentioned a couple of times already, GitLab strives to be the DevOps platform. So they want to integrate and offer all the features that are part of the CI/CD pipeline, or basically the whole application lifecycle, from the development, which is hosting your code in a repository, to all the Git workflows, etc., as well as all the features and tools for building the application, using all these types of registries, but also the final deployment phase, right? And for deployment management in GitLab, we actually have this deployments section with all these things that are related to deployments. And when we deploy our applications, of course, we want to secure it and want to monitor it to make sure that everything is running correctly, and it has security and monitoring also integrated inside. So GitLab basically wants to build a platform where you have all this out of the box. So going back to our deployments and environments, let's actually click inside the environments. And right now you see that we don't have any environments or any endpoints of deployments for our applications. So let's actually configure our CI/CD pipeline to add a deployment environment in GitLab UI. Right here, we're going to have an overview of what we deployed to which environment and what is the endpoint of that deployment. How do we do that? It's also pretty easy. In the deploy job, we're going to add an attribute called environment. And environment has a couple of parameters. One is the name, so we can give it any name that we want. Let's call it development. So that's a dev environment. And it has the endpoint. So for example, if you have a proper domain configured for the application, this could be dev.myapp.com or something like this, a subdomain, whatever. And then for staging, you may have something like this and so on, right? So in our case, we have this public DNS and the port 3000 as an endpoint. So we can use that as a URL. And this is going to be HTTP. And there you go. Now, in our case, we can access the application on dev server using either public IP address or the public DNS name, right? So basically, we could reuse the value of dev server host as a URL as well, but in practice, it's not always the same, right? So SSHing into a server may have a different endpoint, and the application itself will have its own endpoint. So these two can be different. So in this case, let's differentiate them and let's use the public DNS as the URL. And again, not too hard coded. I'm going to reference it as a variable, and let's call it dev endpoint. And right here, we're going to paste the value. And note that when this pipeline runs, GitLab will see that we have environment attribute defined here. So it will see that there is no environment with this name. So it will create one on the first run. And on the successive runs, it will basically know which environment we are deploying to. So now GitLab will know that this deployment basically applies to the environment called development. Let's commit the changes. So the commit will trigger a pipeline. And in order for the deploy to work, let's actually stop the running Docker container. Otherwise, this build will fail. So let's do Docker stop container ID. Otherwise, it will complain, obviously, that port 3000 is already in use. So it will not be able to run that Docker container. So now let's wait for the pipeline execution. So our pipeline has passed. The deployment was successful. And now let's go to deployments and environments. And as you see, we have a new environment here, which is called development. That's what we called it. And if I expand it, you see the status, the last deployment to that environment, which was 5 minutes ago, from which commit it was made, and so on. So this actually gives you a pretty nice overview of what commit or which state of your code is deployed to which environment. And the open link here will basically take you directly to that URL that we had to put together before and gives you a shortcut access to that environment. So this is additional nice feature of GitLab. And of course, when you have one environment, it's obviously easier to manage. But when you have multiple environments for multiple applications, this can be actually really helpful for knowing exactly which commit is deployed where, what is the state of the deployment, and when was it deployed last. And you can show even some more additional details, like which branch is deployed, from which job, as well as which GitLab user or team member basically triggered that deployment. And again, you have direct links to all of those, like going directly to the logs of that build. So in the previous video, we have added a deployment step to our pipeline, but our deployment is pretty primitive actually. We're just running docker run command and starting one container, and that's it. And now if I actually changed the version, and let's say we wanted to build a new image version and deploy that using the pipeline, let's see what happens. So the pipeline failed, or the deploy job failed, because we already have a container running on port 3000 on the host, so a new one cannot be run. So docker run command only works the first time when the container isn't running yet, and after that it will fail. So that's one problem that we have. Another problem or another issue would be if we actually wanted to deploy some other containers for our application. For example, if we needed a database for our Node.js application, or maybe we have an authentication service and some other additional stuff that our application needs, all of which should be run as Docker containers. So how do we run multiple Docker containers in the build without repeating this docker run command? And for this type of cases, we have Docker Compose, right? So Docker Compose basically lets us define a configuration of all the containers that we want to run as a list. And for each container, we can configure the ports that we want to open. Maybe we want to set some environment variables for those containers, etc. And we can define all of that in a Docker Compose.yaml file in a YAML format, just like our pipeline code. And we can just start everything defined in the Docker Compose using one Docker Compose command. So let's do that for our application. And let's create a Docker Compose.yaml file where we configure how our application's container should be run and deploy it using Docker Compose command. So we're going to make a change in the pipeline script as well as create a new Docker Compose file. So those are two changes that we want to commit as one. So it's not just a change to a pipeline. So what I'm going to do is I'm going to go to the files and I'm going to actually switch to a web IDE stage. So that's basically having your code editor, but in a browser on GitLab platform. And that's actually another cool thing that GitLab offers. You can have an online code editor for your project. So this is the standard view of your application, and this is a web editor view. So now in this web editor, I can create new file, for example, and let's call it Docker Compose .yaml. And writing Docker Compose YAML file is super simple. We basically have a list of services, which are our images or applications that we want to deploy. We can give each service a name that we want. So let's call the first one app. Very simple. It's just going to be app. Then for that app, we have image, because Docker Compose needs to know which image are we using to deploy the container. And if we go to container registry, so this is the image that we want to deploy. So I'm just going to copy that, paste it in here, and we need to configure the ports, right? 3000 on host, 3000 in the container. Now, as I said, you can add other configuration stuff here. You can add environment variables, volumes, or whatever. We have just a simple use case. So this is exactly the same as what we're doing in our pipeline. Right? So this command is basically corresponding to this configuration. Let's actually fix the indentations here. Like this, and there you go. And as you see, as I opened a new file, it opened in a new tab. So we can actually work with multiple files at the same time using this web IDE. Right. So Docker Compose file is ready. One more thing we need to add here is fixate the version of Docker Compose. So I'm gonna use 3.3. You can check whatever the latest Docker Compose version is and use that one. And now that we have this Docker Compose file available in our project, let's use it to start the container instead of the docker run command. So we're going to remove the docker command and do docker compose, and then the docker compose file that we want to execute, which basically will start any containers or services defined in this docker compose file. And finally, we want to run it as detached. So in the background, just like docker run command. So that's it. Now, if we run this pipeline multiple times, again, we will have containers that are already running that we would need to stop first. And we can do that easily using Docker Compose. We can just say docker compose.yaml down. So down will basically do the opposite. It will go through the Docker Compose file. It will find all the services defined here with the images, and it will stop all the containers that are running from this definition, and then start all the containers with that definition. And this will not fail even if there is no container running from the Docker Compose file. So we are safe to run it as many times as we want. So whether it's the first time executing it or not. Now there are two more things we need to do to make this work. The first one is that we're executing Docker Compose file on the dev server, right? So just like we installed Docker and made it available there so that we can execute Docker commands, like Docker login in this case, we need to also install Docker Compose on our dev server to be able to run Docker Compose files, right? So these commands will execute inside the dev server, not in GitLab runner. This is the command that will execute on the GitLab runner. So in order to do that, we're gonna SSH on our dev server and then basically just install Docker Compose. And to get the command for installation, I'm just gonna do Docker Compose. It will give me the install command. I'm gonna execute, and there you go. Very easy. Docker Compose should now be available. There you go. Another thing is that we're executing the Docker Compose command on the dev server, passing the docker compose.yaml file. If I do ls now, you see we don't have any Docker Compose YAML file here, right? Because that file is only in the repository. So the whole code is available for GitLab runner, but it's not available for dev server. So what we want to do is that we want to copy the Docker Compose file from the GitLab runner to the dev server, right? Before we execute Docker Compose command. So either in the before script or inside the script, doesn't matter, we're gonna execute secure copy command. We're gonna use this option to disable strict host key checking. we're going to use the private key. And we're going to provide the source of the file and the destination. The source is current directory, docker compose.yaml, and the destination is the dev server and home directory of Ubuntu user. So that's the default location, basically, where the SSH command will be executed on in the Ubuntu user's home directory. So we want to copy that Docker Compose file right here. And that's it. So this will take care of copying the Docker Compose file to this location. And this will take care of then executing Docker Compose command using that docker compose.yaml file. So now we have those two changes. One is a new docker compose.yaml file and one is changes in our deploy script. And let's actually commit those changes and run our pipeline. And if I do commit, you see that we have an option to create a new branch and then start a new merge request, or we can commit directly to main branch. Now, usually in a typical developer workflow, you will be working with merge requests. So even if you don't create feature branches, you would still create a merge request and not commit it directly to main branch. In our case, we're just going to commit it directly to the main branch, which will then trigger a pipeline. And you see that pipeline was created, and you again have this different view of the pipeline. You have multiple ways of viewing your pipeline and links to it. In a web IDE, that's the view of the pipeline. So the run unit tests job is running in the test phase. And let's actually wait for the whole thing to execute. So our jobs ran. Again, we have an error in the deploy job, which is because we didn't stop the running Docker container before. So before executing a pipeline. So Docker Compose will not be able to stop this container because it's not defined inside the Docker Compose file, right? So it cannot reference it using the container ID, for example, or the container name, because it was not created using Docker Compose. That's why we have to stop it manually. And now we can actually rerun our pipeline. Let's do that. So this time our deployment worked. And in the logs, we see the copying of Docker Compose. And we can also check that. So we have the docker compose.yaml file on dev server. And if we do docker ps, our container is running using the service name app that we defined in that docker compose.yaml file. Plus, when Docker Compose starts containers, it actually adds the folder. So the current folder's name as a prefix to the container name. So we have Ubuntu app, which is the service name, and one as a container name. And again, our application is running and accessible. And in the environments tab, we should see the last deployment was 8 minutes ago when we updated the docker compose.yaml and gitlab ci.yaml files. And if we open, our application is running and accessible again. So now you could add any other containers here on this Docker Compose list, like a database service, messaging service, whatever service you want for your application, and you wouldn't have to change anything in your CI/CD pipeline code. So let's close this pipeline view and do a couple of optimizations to this part of the pipeline logic. First of all, if we check Docker Compose command and this F command option that specifies the Docker Compose YAML file, you see that we have a default, which is docker compose.yaml, right? With YML extension. So this means if we are using docker compose.yaml, that's the name of our Docker Compose file, then we can actually leave out this option and have a little bit less code. And I believe it actually works with YAML extension as well. And we can try that. So let's remove these two since they are already the defaults. So that's one optimization. Another optimization is that currently we have the image name and image tag hard-coded in our Docker Compose file. However, when we're building new images, obviously the version of the image will be updated, right? So we don't want that to be hard-coded in the Docker Compose file, so we have to manually adjust it all the time. Instead, we want that to be dynamically set with the pipeline logic. So what we're going to do is we're going to parameterize this, and we're going to reference these values using environment variables. So we're going to do image name. So that's going to be one environment variable, and image tag will be another one. And note that we have a syntax here with $ curly braces. So that's how we reference environment variables in Docker Compose. And this way we don't have to hard code those values. So now that we're referencing these variables, we have to also set them, right? So basically what we are looking for is before we run the Docker Compose up command on the dev server, we want to export those variables, right? We want image name equals whatever the value, and then image tag equals whatever the value. And we want our pipeline to export those environment variables. How we do that? Very simple. Right here, before we actually execute the Docker Compose down and up commands, we're gonna do those exports. So we have image name, and we have the image tag. And right here we can actually hard code the values, but we don't want to do that either. Instead, we're gonna reference those values right here, right? So now we have a lot of references. However, the good thing is that we have one place where we define the values for image name and image tag, which is in the variable section. And then wherever we need that, we just reference them through variables. So we just take the image name like this and image tag and set them as environment variables on the dev server. And we have to do end, the end of each command. And note that these two can be different, right? So this is an environment variable inside GitLab runner, which we create right here using the variables. And these are the environment variables that we're setting on the dev server, which are referenced in the Docker Compose file. So this could actually be Docker Compose image name, Docker Compose image tag, and we're gonna set them like this, right? So these two do not have to be the same. So with these optimizations, we can run our pipeline again. So this time we're not gonna start the Docker containers or the Docker container. It is still running. We're gonna commit directly to main branch, and the pipeline will build and deploy a new image to the dev server. And since our pipeline has passed, let's just validate that everything was successful. Go to environments, last deployment, and the application is still running. So now we have a Docker Compose that doesn't have hard-coded image name and image tag inside, as well as we have a little bit less code by eliminating the default Docker Compose.yaml file as a parameter, because that's a default. With that, we now have a basic structure of a real-life pipeline for our application that runs unit tests, builds an image, pushes that image to a Docker registry, and then deploys it using Docker Compose on a development server. And we have everything parameterized. We're not repeating code or hard coding different values throughout our pipeline logic. At this point, our pipeline looks like this. We have 3 stages where we're running the tests and then building and pushing the image and deploying it to the dev server. So we have created a basic version of a deployment pipeline for our demo application. In this chapter, we will add to that pipeline, do some optimizations, and make it closer to a real-life pipeline by first adding logic to dynamically set an incremented version every time we build an image. So we have a new version tag for our image whenever we execute a pipeline. And we're gonna add 3 more steps or 3 more jobs to our pipeline. First, we're gonna add static security analysis tests for our application, what's called assessed. And then we're gonna add 2 more steps right here to promote the application changes from development to staging environment, and then from staging to production environment. And of course, along the way with all these additional steps, we're gonna learn some more GitLab CI/CD concepts. So let's get started. Now, in our pipeline, we have a hard-coded image tag that we had to manually adjust in order to build an image with a different version or with an incremented version. Otherwise, if we do not increment this version and just leave it at this hard-coded value, we will be creating the same image tags and we will be basically overriding the image in our container registry over and over again, right? So if we keep creating an image with a tag 1.0, we will be basically overriding this specific image with every pipeline run, which is not very realistic and it's not what we want. The idea is that every time a pipeline runs, a new image with a new image tag gets built and pushed to the repository. Because as we develop the application and as we make changes, of course, we want to keep track of those changes and version them. So we're going to have multiple versions of our Docker image. And for example, if the latest version didn't work, we can revert or roll back to the previous working version. However, we want to automate this process of setting the new incremented version for our image tag. We don't want to have to set this manually each time. So we're going to add the logic here that sets the new image version every time the pipeline runs. So first, let's see how versioning applications works in general. For versioning applications, we have multiple options. Different teams use different version schemas and approaches to that, but a standard, very common versioning schema is made up of 3 numbers, like this. So we have the first one, which is the major version for major application changes. This could be like a big code refactoring in our application, or changing or replacing a programming framework, for example. Then we have a second number in our version for minor changes. So that's the minor version. And this could be if we add a new feature or if we did a little bit bigger bug fix and so on. And the third one is what's called a patch version, which is meant for small fixes and changes like changing a button in the UI or making a smaller bug fix and so on. And this whole version is usually defined in the configuration file of the packaging tool we use for that application. For our application, we use npm, and the configuration file for that is package.json. So this is where the version of the application is usually defined. So we have a version attribute and a version schema here. And in our case, for our pipeline, we use this random image, which is hard-coded, but usually the image tag is based on the application version, which is defined in this configuration file. So when we make application changes in the code, depending on whether these are major changes or minor changes or even smaller changes, we're going to increment the respective number of that version. So if we make a quick fix, for example, we're going to increment the patch version. If we make minor changes, we're going to increment this version and so on. So what we want to do now is in our pipeline, in the GitLab CI file, we want to read the application version, which is defined here. Let's make it bigger, programmatically. So in the job where we're building the image, instead of having this hard-coded image tag value, so let's get rid of it. Instead, we want to read that value in the build image job where we need the value. We want to grab that from the package.json file programmatically. How can we do that? It's pretty easy. We're going to cat the contents of the package.json file. So inside the app folder, we have package.json. And then there is a tool called JQ, which is a JSON query language that lets you parse JSON, a JSON object, and get an attribute of that JSON object, like version attribute, for example. So JQ minus R and the version tag. So this simple expression here will basically print out whatever the package.json contents are, and then using this JQ or JSON query language, we're gonna grab the value of version attribute. And that's how we read the application version in our pipeline code. Now, in order to use this JQ tool, of course, we need to install it first. So on the runner that executes this build image job, which is in our case this EC2 instance, EC2 runner with shell executor, this runner has to have JQ tool installed so that it can execute this command. So before we continue, let's go to our GitLab runner and install JQ, which is just one simple command. So going to my terminal, I'm going to connect to my GitLab runner with the GitLab runner key. And using a simple apt-get install JQ, let's install that tool. Awesome. So to demonstrate how this works on a shell, let's grab our package.json just for a test. I'm going to create package.json file here, paste the contents. So now I have this package.json, and if I do cat package.json and pipe it to JQ tool that we just installed, this is going to give us JSON object. So that's how it's going to be without the JQ. So we have the highlighted syntax. And again, if we want to access a version attributes value, we're just going to do .version and we get the value. The same way we can access any other attribute value that we want. Pretty straightforward. So let's go back to our configuration. So this is gonna give us the application version, which we want to, or we need to save into a variable, right? So we're gonna actually save it into an environment variable, and we're gonna export that. Let's say app version equals whatever this expression returns as an output. So whatever this gives us will be saved into an environment variable called app version. And now we can use that environment variable in our script. And by the way, we can take this script and add it in a before script section like this. So this is kind of a preparation for whatever main script or main logic we want to execute right here. So now we can grab that environment variable and use it here, like this. So this is a first step of reading the application version from the package.json instead of hard coding it in the pipeline. And this means the developers who are developing the code, the application, are the ones who are going to manage the application version in the package tool configuration and not in the pipeline. So pipeline shouldn't care what the version of the application is. However, now we have a problem that someone needs to manually adjust this version here, right? So on every commit, on every pipeline execution, basically this version should be updated manually, or we're going to be building the same image tag again. So we're going to be overriding the image and have the same problem of not having versioned images for our application changes. So that's the second part that we're going to implement now. So we want to generate a unique tag for our image on every build. And how can we do that? Well, as part of our application version, we can use values of one of the GitLab's predefined environment variables. So if we go to the predefined variables list and search for something like pipeline ID, this, for example, will give us a unique ID of the pipeline, either on a project level. So for my Node app CI/CD project, each pipeline execution will have its own ID, or we can also grab a unique ID of a pipeline across multiple projects that I have in the same GitLab instance. In our case, let's go for a unique pipeline ID for the project, because we're building the Docker images for our project, so it has to be unique for that specific project. So I'm going to grab this variable, and we're going to use that as part of our application image. So it's very common when building images in a CI/CD pipeline, generally on any CI/CD platform like Jenkins or GitLab, doesn't matter. It's very common to append the build number or build ID value to the application version. So either append it right here as some unique build ID, or even use it as a replacement or substitute to the patch version. So this will basically represent some build ID or build sequence, or in our case, a pipeline sequence. And this number will be unique for every pipeline execution. And this will give us a unique image tag with every build. So let's try to combine this and build our images with a dynamically set unique version. In our case, let's actually go with the pipeline ID as a substitute to the patch version, which means as a version, we're going to set major minor version, and we're going to append this third version in our pipeline. So for that, we are first reading whatever that version is from the package.json and saving it into a variable. And let's actually call this package.json version. And then on the next line, we're exporting the final version, and we're using package.json version. So whatever is defined here, 1.0 in our case, and we're appending the CI pipeline's ID for the project at the end. So this will give us the 3-numbered version schema, where the third or patch version will always be unique. And then when we build the image, we're going to use this final version instead, like this. Now, using this approach, whenever developers make application changes and they commit them, a pipeline will get executed and the patch version will be incremented. Now, if they make any minor or major changes, they can go to package.json, adjust the version here as part of the application code changes, and this way they can increment major or minor versions. So this will still be done manually. However, the patch version on every commit will be automatically incremented in the pipeline. Now, of course, you can extend the logic to automate updating or incrementing these two versions as well, but at this point, automating the patch version update should be enough. Okay, so now we're building the image with a new unique version on every pipeline execution, but we also need to push that built image, which means we need that version that we just calculated and put together in this build image job. We need that version also in the push image job. But here's the problem. Since we're setting this as an environment variable for build image job execution, the value of the version environment variable is only accessible for this job. For any following jobs, this will not be accessible because, as we've learned, every single job gets executed on its own new environment. All the previous configuration stuff for the previous jobs gets discarded. So any environment changes or configurations set here will not be available for the following jobs. So how do we access this value inside the push image or then deploy to dev jobs? Now we could also calculate and put the version together in those jobs, but we don't want to repeat the code and have such a redundancy. So how do we share any values that we produce in one job with the following jobs? Well, that's where the concept of artifacts comes in again. We already learned about the artifacts in the video about running tests where we exported test reports. So artifacts is generally used to generate any files or artifacts as a result of a job execution, and we can then download these artifacts in the GitLab UI. But we can also use artifacts to pass these generated files to the following jobs. So artifacts is used in GitLab CI/CD to pass any intermediate build results between the jobs. So in case of the test reports, we generated reports to download them and maybe view them in a respective software. In this case, we can use the artifact to generate a file that contains the version that other jobs can access. So let's see how to do it. It's actually pretty simple. In the build image job, we create a simple text file that contains the value of the version's environment variable. So after we generate this version, we save its value to the text file. So we're going to do echo version, and whatever that echoes, we're going to pipe it or direct it into a file, and let's call it versionfile.txt. So it's a simple text file. So this creates a file in this job. However, we have to persist this file so it's going to be available for the next jobs. And in order to persist a file, we're using the artifacts attribute. Using the path attribute, we're saying, please persist this version file.txt as an artifact so that we can, one, download it and browse it in the UI, but also can be available for the following jobs. And that's it. So this will make sure that the file is available for the rest of the pipeline. Now, when the build image job is done, the version file.txt artifact will be uploaded to the GitLab server, and it will be then downloaded in the execution environment of any following jobs. Okay, so we're saving the version file in the build image job. Now let's see how to use it in the push image job. Or how do we reference an artifact saved by a previous job? Now, to access the contents of this file, we will simply print out its contents, just like we did here with the package.json. So we're just going to say, give me whatever is inside that text, and the same way we can assign it to a variable. So let's call this variable version, and whatever the results of this command execution will be saved into an environment variable called version. So now we have this version value also available in the push image job. Now the question is, how does the version file.txt artifact become available for other jobs in the pipeline? Do we just have access to it by default in this job, or do we need to do any extra configuration to actually get that file? Because in this logic, we're just assuming that file is there for the push image job without any extra configuration. Well, by default in GitLab, all the artifacts of the previous jobs will be automatically downloaded and made available for jobs in the next stages. This means if jobs in test stage and build stage produce artifacts, all of these artifacts will be automatically downloaded and made available for all the jobs in the next stages. In our case, the next stage is deploy stage. So deploy to dev job will have these artifacts automatically. We won't need to do anything there. We can just simply read from it, assuming it is available. However, the push image job is in the same stage as the build job. They're both in the build stage. So this rule that artifacts are automatically downloaded and made available does not apply here because it's in the same stage. So what do we do in this case? Whenever we want to use an artifact from the job in the same stage, we need to use an attribute called dependencies on the job to tell GitLab, please download artifact that this other job created and make it available for this job as well. Not just the following stages, but for the job in the same stage as well. So the dependencies attribute basically is a list of any jobs from which you need to grab the artifacts from. In this case, it is the build image. So with this configuration, even though push image is in the same stage as the build image that is creating this artifact, we will still get that version file artifact and be able to use it in the push image job. So with all this configuration, now we're specifying that in the build image, we want to save this file as an artifact, as a job artifact, which means once build image job completes, the artifact will be uploaded to GitLab server and basically persisted and saved there to then be downloaded in other jobs. Then GitLab will execute the next job in the same stage, which is push image. It will see there's this dependencies attribute that references the build image. So GitLab will download all the artifacts that this job generated. So this could be a list of files and directories, whatever artifacts we wanted to save here. So it will download all those artifacts in the job execution environment of this job and make them available for use. So that's how it's going to work. So we're going to read the version and we will need to replace the image tag with this version environment variable. Now you probably already noticed that we're using both dependencies and needs attributes together. And these two actually seem to have similar meanings, right? We're saying the push job needs build image job and it depends on the build image job, right? So it kind of sounds like they're doing similar things. So here's how it works. Needs and dependencies attributes have different purposes, but they do overlap in their functionality. So the needs attribute specifically says that push image job needs build image job to complete, so to be done and complete before push image job can start. And it actually needs the build image job to complete successfully before it starts. So if the build image job fails, then this should not be executed, which is logical because we can't push an image that we haven't built. Great. Now dependencies, as we said, is the main purpose of dependencies attribute is to tell GitLab that this job needs an artifact from the build image job. And again, this is only needed if they are in the same stage. However, there are actually overlaps on needs and dependencies attributes, and when they are used in combination, they actually affect each other. One of the overlaps is that when we use both attributes on a job, GitLab can only download artifacts of the jobs that are listed under needs. So for example, if we had some other job here like this and not build image, then this will not work. We would actually also have to include build image in order to be able to download the artifact or use this dependencies attribute. So in this specific case, needs will actually affect the functionality of dependencies. And another interesting overlap is that when we use needs, it actually already implies the dependency, which means in this case, GitLab will wait for the build image job to complete before starting push image, but it will also download any artifacts from that build image job. And as a result, we actually do not need to use dependencies when we have needs attribute already, because this will be implicit dependency as well. So again, important to differentiate that needs and dependencies have different purposes, but when used in combination, they actually affect each other. Now, let's say in the next stages, we have several jobs that don't need that versions file at all. Let's say after deploy to dev, we have another job here that tests the deployment on dev. So test dev, and we have a script here that basically does some testing, but it doesn't care about the version because we don't need that in the logic for testing. In this case, we can actually tell GitLab not to download the artifact files from jobs of previous stages, because as I said, by default, that version file artifact will automatically get downloaded for this job if it's in the next stage. And we can actually prevent that from happening by setting the dependencies to an empty array. So this will tell GitLab, do not download any artifacts of any jobs of the previous stages. We don't need them here. And this can be helpful if you're producing a lot of artifacts in your pipelines and you don't want to waste your bandwidth and time for fetching all of them from internet for jobs that don't actually need those artifacts. Or it could be that your job only needs artifact of one of the previous jobs, so you can specify only that one on the dependencies list. So let's say here we need an artifact that the test job produces. So this will make sure that only the artifacts of run unit tests build will be downloaded and made available for this job and not the others. So basically with dependencies attribute, you can control which artifacts from previous jobs get downloaded and which don't. So let's clean this up, and we're gonna now use the version or read the version in deploy job. So right here in the before script of deploy job, I'm going to add exporting version environment variable, reading from that file. And again, we don't need to specify dependencies here. It will be automatically available. And I'm going to copy the version and replace the image tag with it. Now we can search if we have any image tag left in the pipeline. That's it. So instead of hard coding the version, now we are incrementing the version on every pipeline run. And we are using that incremented version to build the new image, to push that image to the repository, and then to deploy that new image to a deployment, to a development environment. And everything looks good. So now let's commit our changes and see the output of the pipeline execution. Edit dynamic version increment for patch version. And I actually need to do that in the root directory. So let's check again. Git commit amend. So we're adding this in the same commit. And let's push our changes, and this should actually trigger the pipeline already. So let's go back, and our pipeline is running. So let's wait for the output. Then we're going to see the image tag that we built. So first of all, our pipeline has passed through all the stages, which means we should have a new Docker image in our container registry. So let's go inside in our root image, and right here you see the base version, which is the major minor version in the package.json. And then we have the unique ID of the pipeline build, which is 121, which actually corresponds to the number of times we have run the pipeline. So in my case, I have 97 here, but I have deleted some of the pipelines. So in total, that will actually be the number of times the pipeline has run. And that means if we change something in our code, and let's actually change something that we're going to see in the deployment. And let's say right here, let's do software engineer instead, commit. And once the pipeline has passed, Let's again go to our registry and check the image tag. And as you see, we have a new image tag with a patch version, which has incremented from 121 to 122. So that's the number of pipeline execution in our project. So if you don't have any pipelines deleted in your project, you should see the number here as well. With this, we have optimized our pipeline, and instead of manually changing the version, we are incrementing the version automatically with every pipeline execution, which is exactly how the real world pipelines for applications should work. And this way, we're building a history of Docker images for each application change. So if we want to go back to a specific Docker version, then we can use that image tag to deploy that specific image. And we can also check the deployment. If I refresh, right here we have software engineer instead of software developer, which is the change that we made. Now, there is one more thing I want to teach you about regarding the sharing of artifacts between the jobs. What we learned in our demo is a generic way of producing any file with any value and making it available for the next jobs. But in our case, we are saving and passing an environment variable, which we read out from the file again and export it as an environment variable. And for that specific case, GitLab actually has a dedicated feature to pass environment variables between the jobs. So let's see how that works. It actually needs a little bit of adjustment. First of all, instead of saving the environment variable file into a .txt file, we need to save it into a file with .env extension. So let's say this is build.env or env file. So that's where we're saving it. So that's the first adjustment. And we need to actually save the environment variable key value pairs, not just the value, not just one thing, but it has to have a specific format. So basically, we're gonna save version equals whatever the value. So this could also be image tag, it doesn't matter. We're gonna call it version for consistency. So we need to save environment variable equals whatever the value into build.env file. And you can save multiple such variables, environment variables, into the build.env file, say my env and some value. But in this case, of course, we would need to append each key value inside the file, right? So instead of overriding the contents inside, we would basically do this, right? Which is a syntax. It's a simple shell, Linux shell syntax for appending a value inside the file contents instead of overriding everything. So that's basically going to be the way we save that environment variable into build.env. And here in the artifacts, instead of this generic path, we're going to say reports, and then inside that .env attribute, that references which environment file we are saving. So this is specific for environment variables. And now in the jobs where we actually need that value, this environment variable that we are saving here will be automatically available as an environment variable. So GitLab will actually do this, exactly this part. So export version equals whatever is inside for you, which means you don't even have to read it out from the file and then set it and export it. This will be basically done for you, which is super convenient because you don't have to worry about reading the values out of the file. It will automatically get exported and made available for you. Same goes here. You don't need to read it out of the file. Now in this case, same rules apply when it comes to using these dependencies and needs. So the dependencies attribute that we talked about and how these environment variables are made available for the jobs applies exactly the same way as for the generic artifacts, which means for the jobs in the next stages, it will automatically be set. For the jobs in the same stage, you need to either have needs or dependencies attribute. And again, the same way you can decide not to inherit those environment variables, Let's say if you have jobs where you have your own environment variables with your own version, value, whatever, you can actually set it to an empty dependencies array, which tells GitLab, do not inherit or set any artifacts from the previous jobs here. We don't need that. And we can also run this and test that it works with this configuration. Set dot env artifact. And as you see, the push image job was successful. We have a pass state. This time, there was no need to download any artifacts because it's an environment variable that gets set in that job's execution environment. So we don't see logs about artifacts being downloaded. And right here, the docker push image name version command has succeeded because the version environment variable was automatically exported for the job. So as you see, when you want to pass environment variables, this is actually a little bit more optimized way of doing it. In our case, it doesn't really matter because we have just one environment variable value. But if we had 5 different environment variables that we wanted to pass to multiple other jobs, then this will actually be the correct and much better option to use, because it would be hard to read 5 different environment variable values from a .text file, because how do you parse them, right? But with .env feature, you don't have to read those environment variables. GitLab sets them automatically by default for your jobs. In our case, we can actually stick to the generic option of passing values between the jobs, just to learn the concept of how to do it for any file and any value, not just environment variables. And we can continue our demo with this option.